Welcome to Physical and Chemical Properties. We are in Learning Target 2 of Matter. First thing that we're going to start out with, what is matter? So if you guys recall, back from when we learned about mass, matter is something that has mass, matter is something that takes up space or volume, and pretty much everything we know except energy and ideas are matter. So then a question. Why do you think it's important to understand the properties of materials we use in our day-to-day life? So, for example, if we were to look at a car, what kind of materials are found inside of a car? Maybe metal, plastic, maybe there's cloth for your seats. What kind of properties do those materials have? And do those properties contribute to the function of that material? So in talking about properties, the first thing we're going to learn about are physical properties. Physical properties are something that can be observed without changing the material. So we can physically take a look at this ice cube here and say, well, a physical property is that it's clear and that it's cold. A physical property of this hot dog might be that the hot dog itself is brown, the bun is a light brown, that it's squishy, that maybe the condiments are wet. Those are things that we can use to describe a physical property of a material. We don't have to change anything on there in order to list its physical property. So some examples of physical properties would be the color of the object. I described the ice cubes as being clear, the hot dog as being brown. Solubility is another physical property. So how well does it dissolve in something? Odor, so how does it smell? Hardness, is it really hard? Is it brittle? Is it soft? Its density, which we learned how to graph. Is it more dense than water or is it less dense than water? Melting point, at what temperature does it melt at? It physically might change from a solid to a liquid. And lastly, boiling point. How long does it take at what temperature to go from a liquid to a gas state? So all substances can change form. We talk about those states in matter. Things move from solids to liquids to gas. They might melt, they might boil, and they move between those things. So things always move from solids to liquids to gas through the process of melting and boiling, or we could have them go the other way. They can go from a gas to a liquid to a solid. So we might have a gas that might condense on your mirror of your shower into a liquid. That liquid, if it's outside and it's cold enough, can turn back and freeze into a solid. So does a change in state qualify as a physical property? So if we go from that gas to that liquid to a solid, is that a physical change? Can we describe that? Or would it be a chemical change? So there's actually no change in no change in that composition. So if we start out with a liquid, that liquid gas is like a fog or a steam. It's still water. When it condenses and it turns back into a liquid, like rain or in your shower, it's still water. And if we were to stick that water into the freezer, it's still water when it freezes into that solid state. So we could still describe its physical property even though it changes from one state to the next. So physical properties do qualify, or state changes do qualify as physical properties. Last thing we're going to talk about will be our chemical properties. So chemical properties that are different from physical properties is that matter is usually permanently altered when making the observation. So it basically changes its form from one thing to the next, and it does so by reacting with other matter. And some examples of chemical properties would be rusting, burning, corrosion. All of those, so things that corrode would be your pipes might corrode. Rusting, you've seen cans rust, you've seen metal rust, cars will rust. Burning, if you light a candle, all of those are examples of chemical properties. What we start with and what we end with are not the same thing. So in my baking example here, that's an example of a chemical property. We start out with the batter that's in a liquid form. Once we go ahead and heat that up, we get delicious chocolate cake. However, it's not the same as it was at the beginning. In the beginning, we would say it was a liquid form, and we would say that the egg was in the liquid form. As we go through the process of heating up and warming, that egg is going to solidify. The baking soda or the baking powder will cause that flour to create a reaction to make it light and fluffy and rise up. So flip your sheet over. You have a chart. Physical or chemical. So on this chart, you need to identify of all those items that are up there, whether it's a physical change or whether it's a chemical change, and write that in the boxes. Thank you.